Hey, by the end of the last video, part 1 of measuring DC motor speed, I was attempting to measure the speed with a photoresistor. Where is it thing? Here's the guy. And some lamps. These guys. The light sensor was trained right on the motor's painted gear. Remember that thing? Just like that. I had it all set up like that. It didn't work. I was using a mid-range multimeter, the X-Tech EX330, and I actually highly recommend it. I quite like it, especially this non-contact voltage detector. It's really safe for household voltage and stuff. But the frequency counter function, the hertz meter, it just wouldn't do it. Not for the signals that we were generating with this thing and ambient light. It wouldn't measure it. I have a professional meter here. The Fluke 87.5. It's considerably better. Let's try it again with that. There, it looks like it works. Try it with the light. Yeah, you can see it. Anyway, the ambient lighting is just around here. It's at normal levels. Got pretty good lighting here, but it's in no way directed straight at this thing. You can see that only half of it's painted, just as before. So we should get 2 signals per revolution. One rising edge as it goes up, one falling edge as it goes down, just like that. So I expect to see it should latch on to either the exact speed in revolutions per second or double it. I'm gonna bet double it. What do you think? So that means this thing has a maximum speed as 6,600, 110 hertz. I think we're going to see 220 hertz on this thing, somewhere around 3 volts. Let's check it out. Guess we can measure input voltage at the same time. let's get a better idea as to what's going on by going up to the top of the range, and it should be around 6,600. There, that's about 3 volts. Oh, lost this guy. There we go. There we go. So 98 hertz. It's measuring the RPM directly. What is it? 100 hertz is 6,000 RPM, so this is just under 6,000 RPM. So it's running a little bit under spec because we're at 3 volts, supposed to be at 6,600. Could be for a variety of reasons. I'm guessing it's because I've beaten up this motor a fair amount. Let's see how low we can go. Now here's the bottom of the range. It's supposed to be, this motor isn't specified for less than 1 volt, and it's running at 28 hertz. Let's see how low it goes before it stops. I'll just ramp it down until it stops. Ooh, look at that. 0.3 volts, so it's still going. But I can keep it going. Yeah, that's cool. Crank it back up. Well, there you have it. You can measure speed. Doesn't really work for this guy. You can see the frequency counter here. It's not working. Oh, it's locking on. Did for a short period. I saw the number. But anyway, it's not nearly as good as the Fluke here. It's quite solid. Probably has a lot to do with the Fluke being something called a true RMS multimeter. Oh, it says right there. True RMS multimeter. You probably can't see it. That just means it can do a bit of signal processing. Next, I'm going to try to do this with my little torque meter here. So, pull that off. I've got a little arm that fits on there. It's a tight fit, so I'm not going to be able to press it on fully right now. You'll just have to trust me. It fits on there. We'll try spinning that and then putting the meter right next to it like this. You can see I'm doing it at 6 RPM. The motor goes quite a bit faster. We'll try it out.